I'm so smart. Does 5 minutes sound good? Everyone can do the good old college try. Okay, let's have a quick show of hands. Who thinks 5 minutes will let them move further in the problem, understand things, get stuff? Okay, that's worth it. Keep going.
Yeah, so you've got to add the match and multiply it with the weight. When you get the limit, you can multiply by the matches of the box and extra. I overdid it. We're figuring out the hour. But then person's throw. I think one might be starting. Yeah, the negative one. Or no. Yeah. So yeah, I did this part. Why should I say so? For static, define just right. So yeah, okay. Sorry. Yeah. Okay. Okay, good. Okay. Yeah, it's before it becomes such yeah. Proceed, you want to just put
True or false? Yes or no? Yes or no? Is it less than? Is a yes or no question. Okay, put in your answer. It's time. Give me your best shot and hit enter. And that's time. I am pleased 65% of you, more or less, got at least the magnitude correct. Uh, at least as of 2 minutes ago. I didn't grade necessarily the very last submissions. I'm not sure if that bumped it up or down. Anyway, at least 2/3 of you got the magnitude correct. Only about 20% of you got the direction correct. Both of the directions are leftward accelerations. So I want to go into direction a bit more. Finding the direction is important. It's not the entirety of the subject, but it is it's important, and that connects with lots of things. Being able to identify the direction of acceleration, the direction of a force won't just help you with friction; it'll help you with everything. For B, the results were similar, a little bit better, and for C was great. Y'all were able to identify that. Well, the people who got part A right, at least the magnitude, were able to identify it. So let's discuss this briefly. First off, just the magnitude part. What is the formula for static friction? How could we find the value that static friction always provides? Not always. In this case, yes. We use F equals ma. Why do we use that?
Because you're trying to see what essentially isn't in its place, I guess.
Say that again?
Like you're trying to see where the box is, like where it's why it's not moving, I guess, or I don't know how to explain.
Oh, it's moving. It's moving along with the car, the truck. There's no such thing as kinetic force. You mean
Kinetic friction, sorry.
kinetic friction? Oh, I'm talking about A though.
Yeah. I'm saying you're doing that because you're trying to see how, like, against how I don't know how to explain it, like how the acceleration or how the box is going against the kinetic.
That's true. But why do you use F equals ma?
Oh,
How do you know you can use that?
I guess.
Oh, don't guess. Don't guess. You can know this. Abdullah? That's part of it. Can anyone tell me about the horizontal forces? Or Fernando first. There is an acceleration present. That's part of it. Horizontal force, F equals ma. There's something that everybody is skipping over though. Friction is, yeah, go ahead.
Acceleration of the thing, the truck, that is also equals opposite force.
That is also crucial. That's not what I was thinking of, but I didn't think of that. Bonus points for thinking of something I didn't think of. Good. Yes, what he said, the acceleration in F equals ma is the same as the acceleration of the truck. If the box doesn't slide over the truck bed, that means wherever the truck is, there's the box as well. However the truck is moving, the box is moving in the same way. That's absolutely crucial. For part B, you can't use F equals ma because the box is not accelerating in the same way as the truck is. If there's relative motion, if there's kinetic friction, relative motion, you can't know immediately the acceleration of the box. Good. Yes, I didn't think of that. What I was fishing for, the other puzzle piece that means why you can use F equals ma is because kinetic friction is net force in this case. You can't always assume that. In a minute, we're going to do the truck, and then there are two horizontal forces. And together, those horizontal forces will provide a net force on the truck. But you can't just say any old force is ma. You have to know that that force is the net force. So, since static friction is the only horizontal force, net force means the sum of all forces. If there's only one force, net force is the horizontal force given. we can use F equals ma. And also, as he said, again, a is the acceleration of the truck because the truck and the box are moving together. Talk about 2. You can't use F equals ma. Why? Well, you can't use a equals 3. Why? What did I just say? You can't use a equals 3. Anyone? How do you know it's got a different acceleration? That's right. Exactly. Yeah? Y'all heard that? If the box is moving over the truck bed, it's not moving at the same rate as the truck. It's not accelerating at the same rate as the truck. The acceleration of the box is something else that you don't necessarily know. Now, F equals ma still applies, but if you don't know a, you can't use that to find F. What can you do to find friction force, kinetic friction force? A whole bunch of you got the magnitude, right? What'd you do? I'm gonna shout it out. What'd you do?
The,
Perfect. Mu n is our given equation. For kinetic friction, E simple. You just plug in. Now, let's review also, because there are a couple of, well, this is worth thinking through. This will screw you up if you don't think about it and understand why. How do you find n in this case? Someone else. I like your answers. You're participating. Good. Let's have other people. ma plus g, how much is a in this problem? Anyone know what a is for this truck to find the normal force? Nope. What? Nope. Nope. 0. Normal and weight act which direction? Vertically. Is the truck accelerating up, down? Remember, acceleration, force, these are vectors, they have direction, and the vertical direction, normal force, weight force, don't care what you're doing horizontally. Likewise, horizontal motion is unaffected by weight. Horizontal force is unaffected by normal. Horizontal motion isn't caused by gravity. Yeah? Right? So, Mitzi was right. She said in this case, it's mass times acceleration plus gravitational field. And acceleration is 0 because it's not accelerating. Up, down. If we're looking at vertical forces, use vertical acceleration. Does it make sense that he's not accelerating vertically? Yeah? Remember that A isn't just, A differs if you're talking about up, down A and left, right A. Different directions matter. Okay, so. If you plug in A equals 0, what's Mitzi's equation become? Normal equals mg. Normal is equal to the weight force. Can you always say n equals mg? Did I give you that in his equation? No. Muy importante. You can conclude normal equals mg because net force must be 0 for acceleration to be 0. There are two forces, normal up, weight down. If the total is 0, they must be in balance. So if they're in balance, normal equals weight equals mg. Did I say that too fast? Let me do it again. There's logic here, and you must think through the logic because it won't always apply in the same way. For instance, what we're about to do next will be different. Normal in this case equals mg because here's how I reason through it. As we just said, it's not accelerating up, down. A is 0, right? Everyone nodded their head to that, I think. If A equals 0, vertical acceleration is 0, then what's the vertical net force by Newton second? F equals ma. If A is 0, F is 0. Okay, what's F mean in F equals ma? It's the net force, the total force. There are two, in this case, for the box, there are two vertical forces, a normal up, a weight down. I'm saying that the total of the up and the down added together is 0. How do I add two things together and get to 0? They must be equal. In opposite directions, equal magnitude. You can't have more in one direction and less in the other direction and add to nothing. They must be balanced. Did I still say it too fast? You're still writing as I was talking. Look, let's do it this way. Turn to your neighbor and explain to them what I just said. Then in a minute, I want you to ask a question on the puzzle piece that you dropped, that I said too fast again. Turn to your neighbor and discuss. You have 1 minute.
You're ignoring down, then that's when the A will be present, since side has got to be 0. And yeah, should be equal to each other in magnitude, but opposite direction. And so that the normal force should be mg instead of m a plus g. It's slowing up, then that means it should be more positive than negative. And time. We're going downwards, then also be m minus or m times minus a.
Damn it. Oh, for dog's sake.
I don't know. That is weird.
Okay, time's up. Here's what I said again. Now talk to me. Which piece doesn't fully click? What didn't you say to your neighbor? Here are the logical 4 puzzle pieces. Which of these didn't click when I said it? Don't try to memorize.
I think for me, that's Newton's thing from n minus the weight force.
From this line to this line? This isn't Newton's.
That's what I'm.
Yeah. This isn't Newton's. Yeah. I know, it sucks. I'm sorry, we ran out of letters. So here's how I can do this. Here's how I think of this. If you have a number, space, a letter, that letter means the units, newtons, kilograms, meters per second. These are algebra equations. I never put the units in the algebra. I always just put numbers and variables and letters, symbols in the algebra. At the final answer, I will write down blank, 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 newtons, blank, 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 kilograms. So when you're dealing with algebraic equations, n means normal. It's not a unit. Units don't go in algebra. Units don't go in the algebra. N is normal force. If I have number space n, that can't be number space normal force. It's specifying an amount. That said, I want to step here, Fernando. Net force has 2 things acting on the box. There's an up normal, a down weight. Did you see that for this case? You see that they cancel, but did you know that they both act? Good. And if they cancel, how big must normal be? Bigger or smaller than weight? No. If n minus w equals 0, solve for n. N equals w, which is how I jump to mg. Weight is mg. If these two are different numbers, they can't cancel. Good. Fernando stepped through it, logicked through it with me. Anyone else want to logic through it with me? The next one's harder. Ask here or forever hold your peace. Peas. Yes, please.
The weight force can have the same magnitude.
In this example.
Okay, the normal force equals to mg because they should be the same.
Yes. If normal minus weight equals 0, then normal had better equal weight, and weight is mg. Good. He gets it. Other questions? Okay, so uh, 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 that's A's magnitude, that's B's magnitude. C, to answer C, a whole butt ton of people got C right. I want to go over why Fs we get from F equals ma. Because there is no equation for Fs. There is an equation for the max it can produce. What's that equation? How much can static friction give at maximum? How do you calculate that? Yeah. Yes. Coefficient of static, mu s n. Right. So you know n. I give you mu s. Which mu s, by the way? I told you two mu s's. Which one do you use? Why do you use 0.8? If I'm talking about the box, to hell with the road. Okay? Don't just look for keywords and numbers with the right units or symbol. You got to think about what it's talking about. That's why I gave you multiple numbers here, to make sure that you're thinking about the meanings rather than just looking for cancellation or whatever. Okay. Shh. Talk in a minute to each other, not now. Okay. So we could calculate Fs max with mu Sn. We could calculate Fs. We already did that with Ma. What does it mean? What does it tell us that static friction is less than its maximum value? What can you conclude logically from that? If static friction is less than its maximum value, what do you know? Abdullah. It's moving regardless. Hold on, not moving. The place that it's in over the truck. Yeah. It's going to move with the truck. It's going to say on the roughly middle of the truck bed. Yeah. I mean, I'm quibbling with saying move because it's slowing to a stop regardless. What I want you to say is moving with that is what you said, moving with the truck. It's not slipping. If static friction is not being asked to provide more than it can, then it'll stay static. Yeah.
Maximum. Wouldn't it be just if it passes? Wouldn't it just be kinetic friction?
Yes.
Okay.
Exactly. So if it's less than, we're not in kinetic. We're not slipping. Good. Yes. Feels good. Capiche? Yes, Isabella. I absolutely can. Wait, to do the free body diagram, we have to have the direction of static friction, or of either friction. Let's go back and think about that for a second. Which direction, everyone point with your hand, big and bold, which direction is the box accelerating? Everyone point, big and bold. Show me with your arm, smack your classmate in the face. Well, maybe not. Left or right? Moving right and slowing down, which direction is that accelerating? Leftward. Acceleration is leftward. Remember, if velocity and acceleration point in the same direction, that speeds you up. If you're slowing down the velocity and the acceleration in the opposite direction. Also, I freaking told you A is -3 meters per second. The acceleration vector is -3 meters per second. All right, if acceleration is leftward, which direction is net force? Always. F equals ma. If A is negative, what's F? Negative, right? What does it mean to have a negative net force? Means the total force acting on the object is leftward. If the total force acting on the object is leftward, in this case, tell me about the friction force. The friction is the only force. The friction that makes friction the net force. Net friction force must be leftward. So the correct answer here is negative 300 newtons for the first part. Negative 300 newtons. I mean, also, like, if I give you the vector A and you're using F equals m times A, if I'm asking for the vector, and as I said verbally and wrote on the problem, I'm asking for the sign as well. 100 times negative 3 is not 300. 100 times negative 3 is negative 300. See? Yes, good. That said, Isabella asked for a free body diagram. Which direction should I show the friction arrow? Google form. Question D, were you paying any attention at all? Which direction should I draw the friction arrow on Box's free body diagram? Okay. On average, most people were paying some attention. Good. The correct answer is leftward. Acceleration is leftward, so net force is leftward, so friction is, which is the net force, is leftward. Fernando. Totally. If you're speeding up or moving leftward and slowing down. Yeah, totally. It is not universally true that friction always points leftward, but in this case, since friction is the only thing that exists to slow the box down with the car, friction must point in the slowy downy direction. Okay, so free body diagram time. Box. Muy importante. I'm going to ask you about the truck in a second. So let's talk about the box very carefully here, because you're going to need some of these forces when you analyze the truck. There is a downward weight force, and I want to be precise and specific here. We're going to analyze more than one object, so I want you to write the triplets here. It's important. There's more than one W, but there's only one WEB. There's more than one N, but there's only one NTB. Which way does friction point? Oh, yeah, you all said left. Friction force, and this is stupid. I hate this, but I can't think of a better notation. This is, well, hold on. Actually, this applies for both of them. Maybe I will skip the subscript. If we were specifying which one, or if they were different for some reason, although I can't imagine if that could happen, I would write FKTB, FSTB, but screw that. Both of the frictions are caused by the truck on the box, and I don't actually need to specify what kind here. Free body diagram is the same either way. That's it. That's the free body diagram for the truck. That's the force diagram. Do you like that, Isa? Does that click? Yeah? Good. Okay. Now, let's stick to just the static case. We're going to talk about static friction as the thing that's applying. They're moving with, the box is moving with the truck, accelerating at negative 3 meters per second squared, right? We're going to use that value. Next. Assume box stays stuck, aka static. Let's build this up. I am wary of giving this to you in a single step. I think that that'll kill you. List the forces. List all forces in triplets. You know what? Screw the alphabet. I think that asking people to alphabetize is breaking some fraction of the class. because there are too many steps here. List forces in triplets. If you don't know what I mean by triplets, ask your neighbor. We've only been doing it for 3 weeks, and I'd really like you all to do this. List forces in triplet notation acting on truck. Uh, oh, what the hell? Let's do one piece at a time. This will be E. Let me make sure that you can see everything acting on E. Does everyone have a diagram? Did everyone copy down the diagram? Do I need to scroll back up? You know what's going on? Who wants me to scroll up? Okay, a couple. You all know what I'm asking? List the forces? Yeah. Here's the original problem statement. Hey, I'm not giving you 15 minutes for this. Give it your best shot, and then we're answer it. Okay, time's up. This is where y'all need work. Only half of you got this one. Is the box interacting with the truck? How many forces is the box acting on the truck with? 2, is the road acting on the truck? How many forces does the road exert on the truck? 2. If the road is frictionless, how on hell is the truck slowing down? No, I call road and earth separate. I call road the patch of planet directly underneath you. I call earth the whole shebang. Okay, so the road normals and the road frictions. Yeah. Okay, is there anything else that interacts with the truck other than box and road? Earth. Don't forget about the earth. So there are 5 forces: normal and friction from road, normal and friction from box, weight from earth. Let's talk about the notation for these. I had a fair number of people tell me that the box exerts a weight force on the truck. Write this down in your notes. Oh my God. Weight forces are exerted between planets and objects. Normal forces are two solids pressing against each other. Weight might be equal to normal force, but that doesn't make it the same thing. I believe that Abdullah and I are equals. We have the same rights. We're both human beings. We deserve good things. Well, he deserves good things. I don't believe that we are identical. I don't think we're the same person. Normal might be equal to weight sometimes, but that doesn't mean it's the same kind of thing. Distinguish this. The box can't weight the truck. The box can only normal the truck. They're not both big enough. Unless one of them's yo mama, right? Right? There's not enough mass to be gravitating. Okay, so, crud, I can't test you on F. I can't test you on F. I'm going to list, I can't test you on a diagram. Oh, I can't see a diagram here. But what I can do is I'm going to ask you to identify the directions for each of the forces. I'm going to write them all out. Show me the direction, up, down, left, right of so just put pluses or minuses. Don't say positive, don't say negative, don't say left, right, up, down. I just want to see plus and minus in my grade sheet. Okay. Preparing myself for half of y'all to type P and M. Tell me plus or minus direction for each of these following. Let's see, normal force of road on truck, friction force, which in this case is static, of road on truck, normal force of box on truck, friction force, which I said in this case is static of box on truck, and the weight force of the whole darn shebang on truck. What will these be? F through whatever? F, G, H, I, J. Based on if we get this right, then we get to move on to the equation and solving for numbers. Yeah, let me zoom in. Think carefully. There are pitfalls here, which is why we're doing it. Oh my God, I'm asking for plus minus signs, peeps. Listen. What? Please turn to your neighbor and smack them if they're not following the directions about what I'm asking. F plus or minus, G plus or minus, blah, 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 okay? You cannot possibly become doctors and opticians if you don't follow. Okay, time's up. Most people got the fact that the road upward forces the truck. Good. Most people also got the idea that if the truck is slowing down, there must be a leftward force from the road on the truck. Good. Not as many people got H and I correct, though. Let's go back up to the diagram for the box. Normal force of truck on box is up. What's the direction of normal force of box on truck? Newton's third. Down. Down. If truck on box supports, box on truck oppresses. I mean, think about it. If you're sitting on Santa's lap, you feel pushed up on the butt on your legs and butt, right? If you're Santa, you feel the top of your leg pushed down. From the truck's perspective, it is pushed down by the box. From the box's perspective, it is supported up by the truck. Yeah? Force of friction that the truck exerts is negative, leftward. What direction must the box push on the truck? FTB negative, FBT positive. If the truck left forces the box right forces the truck. How can we visualize this? Suppose you've got a cart that you're pulling along or something, and you're running along and trying to slow down. Does it help you slow down? Or do you have to counter its inertia? This box, its inertia, wants to keep the truck moving onward. So the box is pushing the truck forward, keeping it from slowing down as much. Let me put these here. The force of the truck, the box, for God's sake, on the truck is that way. The normal force of the box on the truck is that way. The normal force of the road on the truck is that way. And I was pleased to see most of you got the friction force. I should say that this is the static friction. This is also static friction of the road on the truck. Last one, which direction is planet pulling? I would hope most of you got that gravity pulls things downward. Okay? Now, I can't test you on drawing these diagrams, but you should do this. And if you goofed somewhere, find out where. We're going to add numbers in for a second, but I want you to turn to your classmate for 2 seconds, 1 minute, and argue about why the directions are what they are. You have to get this or you're screwed, okay? I can't test you directly on this, but it's a necessary part. Ready, set, go.
Oh, what was that? Oh, I mean, it's very simple. Truck slowed down. That means the road gotta go to the friction between the road and the truck gotta.
Okay, we're gonna run out of time. Questions before we do the final step now? Please. Buh. No. Plus minus minus plus minus. Yeah, is what that diagram corresponds to. Okay, now let me remind you, here's how to write a net force equation. Net force is ups minus downses, or rights minus leftses. You just look at a direction and you put them together with plus or minus signs as appropriate. For instance, for here, I earlier wrote n minus w because n is up and w is down. I added them together, accounting for their direction. That's how I got n minus w equals 0 earlier. Great. Now, the next thing is, can you write an algebraic expression for the let's say the horizontal force first, K, and the vertical net force, L. I want you to write an algebraic expression for the truck forces here. Use the triplet notation, NRT, NBT, WET, FSRT, FSBT. And I want you to tell me what net force is in each direction. What did I just say, horizontal first? Okay, so I want you to tell me K, find F net. All you have to write is adding them together, accounting for the directions. L, find F net vertical. Do you know what I'm asking you to do? Write an algebraic expression for the total force in each direction. A whole bunch of people are still screwing up on what is net mean. Where's that go? Where's that go? K is horizontal, L is vertical, peeps. K and L. Oh, my sweet baby Jesus, people are getting it right. Oh, yeah, progress, progress. Yes, yes, yes. Okay, time's up. We're running low on time, and I want to be able to get through this whole sucker. Finish getting force magnitudes as well. The correct answer for K is FSBT minus FSRT. I add all the horizontals together. Lefts and downs are negative. FSBT minus FSRT. Question L, the correct answer was NRT minus NBT minus WET. Or you could say minus NBT plus WET in parentheses, whatever, I don't care. So that's the net force in each direction. What can we say about the value of the net force. What's the vertical net force gotta be equal to? 0. Why? Is the truck accelerating vertically? Are we lifting off into outer space? No. So you can set the vertical net force equal to 0. What about the horizontal direction? Are we accelerating? Yes. How much are we accelerating? I told you, negative 3 meters per second squared. Okay. Write down on your paper, I'm going to have you solve for stuff. Write down the Newton's second law in each direction. You found the x direction, set him equal to ma that I gave you. Your L expression is equal to 0. Now I want you to solve for these values. Let's see. So M is normal force of road on truck. N is the normal force of box on truck. O is the weight force of earth on truck. God help you if you know. FSBT is P. And see if you can get the static friction force that the road exerts on the truck with Q. Write down the algebraic expression, solve it. Yes. Sure. Da, da, da. So, yeah, let me put it in red so it's a little more visible. The x directions. FSBT is in the positive direction, and I add together a leftward FSRT. In the vertical direction, I've got the one thing in the positive direction, positive nRT, minus nBT, minus WET. I will also remind you that we can directly have the values for NTB, FSTB, and WEB there. The box's values are right there. Do you all have the values of mass and stuff for the truck? Okay, chop, chop, quick like a bunny. I really want to see if you guys can do this. All you got to do is write down a couple of lines of algebra and solve it for numbers. Yeah. Numbers. Give me numbers. Here. You can solve for these values numerically. You have everything you need. I'm hinting here's how to do it. Set this equal to MA, set this equal to MA, set this equal to MA with the appropriate A, and solve. You've got every piece you need. Ready, set, go. What did I say? 1,500 or what did I give you? 1,500, yeah. M. Hey, give me, forget the signs for just now. Give me magnitudes, okay? Magnitudes only. I didn't ask for vectors here. Magnitudes only. No minus signs. So I can grade this. Oh, sorry. Hey, for uniformity, everyone round to 10 for G, okay? I mean, I really only gave you one sig fig in all these. Everyone round to 10 for G, okay? I want to be able to see them all. Question. The truck is moving, but the truck is not leaving tread marks. The truck is not skidding over the surface. Rolling motion, normal rolling is static. Common misconception. Just because there's motion doesn't mean that, yeah. Okay, you guys see where to pick up for next class? Further review too. Finish her up, but on the last step. Wait, hold on. I gotta hit stop.